All right, then enlighten us today.
So welcome to this special edition of Source Decoded. What did we decide? Source Decoded 0.05 or something?
This is a special one. Stuff that we forgot in one.
We realized that we should, if we're going to talk about JavaScript, we should go way back and give you some fundamentals on JavaScript. So if you watched our other videos and they didn't make any sense to you at all, then thank you for watching them. But give this one a try, and hopefully it will help you. If you don't know anything about JavaScript, this is the place to start. I was watching a video on the interwebs a couple weeks ago, and this lady at a JavaScript conference said, JavaScript is a hard language to learn, especially if you haven't learned any other languages. And the more I thought about the statement, the more angry I got that she would say such a thing, because it's wrong. JavaScript is an easy language to learn. I better calm down. JavaScript is an easy language to learn. It is probably one of the most accessible and easy to pick up languages ever. And you're in great shape if you've never learned any other languages.
So how can you prove that?
I did an experiment before I came in this morning. I have a son who is 6 years old and a daughter who is 8. And I wanted to make sure that I was right in thinking that JavaScript was really easy. So my kids have made it through first grade math. So I opened up a JavaScript console. And by the way, if you want to try this at home, launch your Chrome web browser if it isn't already running. If you're watching this video in your Chrome web browser, open a new window, and in the address bar, type this: about:/blank. This is a special page that every web browser has that is just blank. So if you type there, you'll get a completely white page. Now right-click anywhere in the page and select Inspect Element. This will open a console that'll slide up from the bottom of your window. And there's a bunch of tabs at the top. Select the Console tab.
So this is in Chrome, more or less.
Yes, this is in Chrome. Well, the other browsers have similar things. If you're in another browser, you'll have to find it yourself.
Sorry.
So this is Chrome we're talking about. So once you get to the console, you'll find a prompt that looks like this, and then it will have a line blinking.
A little cursor.
A little cursor there. You can start typing here. This is a live JavaScript console, and you can just dink around with JavaScript, and really it's the best way to learn. Alright, so I sat my son down at this JavaScript console and said, you do math in school, and I do math at work. So I want to kind of show you what I do at work. So go ahead and type in a math problem. So he did this. He typed in 4 equals, and then he erased the equals because he was really going for a plus and didn't know that he had to hit shift to get to the plus. Plus 6 equals 10. And he did exactly what I asked him to, because that's what they do at school. I said, yes, that's great, and that's right. But I'm going to show you how to make the computer do the work for you. So we erased the 10 and the equals, and I said, push enter. So he pressed enter, and right under this appeared the number 10. And you should have seen the look on his face. He was so excited that the computer could do math.
My dad taught me how to cheat.
I know, that's the kind of dad I am. But this is exactly how I made it through math in middle and high school and college. So his next question was, will it do a word problem for me? And I said, yeah, but that's really complicated. We're not going to get into that right now. So we played around with this for a while. He typed in a few other things, and we learned that you could say 2 minus 1 and get a 1 back, or 30 plus 16 minus 12, and it would give you back whatever. And my daughter came along, and
she's the 8-year-old, right?
Yeah, she's 8. So we have me and the 6-year-old and the 8-year-old, and we're just pounding out stuff on the console, being amazed at what's going on. And my daughter said, I bet I could confuse it. And she typed in a problem that used all 4 of those operations: the plus and the minus and the divide and the other one, multiply. And it gave him answers. And I got that far, and I knew I had proven to myself and the world that JavaScript is not hard. I taught my kids JavaScript. Actually, I didn't teach my kids JavaScript.
The school system
The
did.
schools did, and my wife, who does most of their teaching, does. They know math, they know JavaScript. Okay, so from that foundation, we are today going to teach you JavaScript. If you survived second grade, you should be able to get all this stuff.
So the next thing in the story, though, that I really liked is you explained that, sure, we can do 4 plus 6 and it returns 10, but you then told them, let's save that to something.
Oh yeah. Okay, so 4 plus 6. This wasn't magic anymore. They'd figured this out. And I said, remember that equals sign? Well, here, we can put it around on the other side and use it to put that result into something.
Didn't you do their names? This was a good, their age. So you did their names as the.
So, yeah, that's good. So the first thing I did was D. They have long names, and I don't want to write them on the whiteboard. So we're going to start with D. He's 6 years old. And so we did this, and I showed them that D equals 6. So you can type D on the console now, and you hit enter, and you get back 6. So that's cool. All right, so then we do C equals 8. And they made this connection themselves. What happens if you do D plus C? Well, the D has a 6 in it, and the C has an 8 in it. So when you do this, you're going to get back 14. And that was pretty amazing to them too. So then we went beyond that a step further. We had been dealing with numbers, so I decided to try something new. Strings. Guess I could capitalize my name. We did Dad equals Benjamin. So now whenever you type Dad in and hit enter, then you get Benjamin back. And we did Mom equals Ashley. Now I thought I'd throw a trick question out and see what happens when you do Dad plus Mom, because you obviously can't add names, right? And my daughter said, oh, well, you probably get Benjamin Ashley.
So she figured it out.
Which is exactly what you get. You get Benjamin Ashley.
So she figured that out. It wasn't you. You didn't even have to prod her.
Yeah, she figured that out all by herself. I did some explaining about the quotes. You put quotes around some things, and that turns it into a string. And I asked her, so what is a necklace? And her answer was, what did she say? A string of mummified parasites. A pearl necklace is a string of mummified parasites, apparently. So they get the concept of a string, and this is just a string of letters and other things all stuck together. So you put quotes around it, you get a string. You add two strings together, you get the strings.
A longer necklace.
Added together. And we even did, it's amazing to me the things that kids find intuitive that as adults we sometimes just confuse. I thought I'd throw them another curveball and say B equals 100, and remember Dad equals Benjamin. So I said, what's going to happen when we do B plus Dad? And she said, well, you get 100 Dad. Which is exactly what you get, 100 Benjamin. Well, yeah, 100 Benjamin, not 100 Dad.
Right.
Which, it just makes perfect intuitive sense.
To the kids. Because they're uncontaminated.
Yeah, and me as a programmer, I'm thinking, oh shit, these are incompatible types. How do you add a number to a string, and what's the compiler going to do? But it just does exactly what you'd expect it to do. So, that said, we are now going to teach you the grammar of this language called JavaScript. We talked about numbers, and we talked about strings. These things are called values. I'm not sure how else to explain it. It's a value. A value represents a value. Okay?
To me, it's just, I think what this comes down to is it's very core value, meaning it can't be reduced anymore.
Yeah, we can't go any further down from 14.
Technically you go to bits, but it doesn't make any sense to us at that point.
Yeah, and JavaScript really has no useful concept of bits. So
Precisely.
So yeah, we can't get any further down than 14, and we can't get any further down than boo. Okay, so these are values. There's also operators. Operators operate on values. And this is not a foreign concept to you. Because again, you've done math. Let's have two values. This is a value, that's a value, this is an operator. The operator operates on the values.
So let's do something real quick. So what you're explaining here is you're saying that this represents kind of an action. This is where I got a little bit confused before, because this does something with those two things, right?
Yeah, let's call this JavaScript for English majors. And here we have two verbs, or two nouns and a verb.
Exactly. So this is the action we're going to take on those two nouns.
You could say this is the subject, the verb, and the direct object. If you were a
that's cool.
linguist. Okay, so this is an action that's going to happen on these two things. And there's a whole bunch of operators. The ones we're most familiar with is plus, minus, or minus 3, multiply, 6 times.
Yeah, so we use the star for
14.
multiplication.
Yeah, this is shift 8. And then to divide by 3. This is a slash. It's the one just above your question mark.
Which they call the forward slash.
Oh, I guess the question mark is above that. Boy, I type that 70 million times a day. Yeah.
it just happens.
The question mark is above this. Okay, and that makes sense too, because it's a fraction sort of thing.
Right.
Okay, so these are the math operators. There are other kinds of operators in JavaScript, and maybe we'll talk about those in a minute. All right.
So we got our basic math arithmetic.
Yep. Let's go back to this. If we were English majors again, and we had our subject, our verb, and our direct object, we put all of those things together, and we'd have a sentence. Well, in JavaScript, we call this
sentence
an expression. So an expression is any sequence of things, values, and operators that can
complete a sentence.
yeah, and it makes a sentence. This will evaluate down to a value. So if you were to execute this, you'd end up with 6. That's a 4.
But you meant
really
6.
meant to draw was the number 6. Okay? So this expression evaluates to 6. Expressions can be a lot more complicated than that. You can add a bunch of expressions together, and since you hopefully made it through algebra, you know how the parentheses work. 2 plus 3 plus 6 minus 2 times, be correct, 3. This is an expression, this is an expression, and all of it together is also an expression. So what JavaScript will do, and basically any programming language, is come in here, start inside the parentheses, and start evaluating this. 2 plus 3 is 5, 6 minus 2 is 4. And now, I guess according to order of operations, we're going to do 4 times 3 is 12. This became another expression. Did you see that?
Yep.
And now we have 5 plus 12 is 17.
So it's that simple. So
Yeah.
What you explained is that was an expression, even a complex expression that gets reduced to another expression, that gets reduced to another expression, that then finally gets reduced to a value.
Yeah, and in a different series of videos, we're going to talk about expression trees. And knowing this, it's just going to blow your mind.
Yes.
Okay, so we got values and expressions. Values, operators, and expressions. Now I'm going to hand the marker off to the more artistic Jared, and he's going to talk about variables.
So, like Vince said earlier, he was dealing with kids, and he says, look, you can put this value into something just to kind of to reference it later, right? Mm-hmm. So you had was 6 was stored inside of D. For a long time, I had a hard time with this, understanding what it's doing. But then one day I finally realized how I could draw it up because I'm an artist and I like to see things visually. And when I finally grasp it visually, I can then understand it better. So what I realized is that when you plug this, when you say 6, you're just sticking it into memory. And when we stick it into memory, we're like, I really want to reference that. You know, when he just said 6 enter, it just, you know, plopped the 6 back, or 6 plus 4 was 10, and just 10 was never stored anywhere. Now 6, if we do, what I mean by that is this. Here, let's see this.
So you have values. Right?
Yes.
There are values in the language, but we want to be able to hold on to them.
Yeah, so you don't just want to execute it and then lose it forever, right?
Right.
We want to say, hey, we want to store that value, and how we do that is we tie a reference to it. So that's how in JavaScript, let's draw it visually first, and then I'll draw what the language looks like. But what essentially happens is we have the 6 value up here, and it's in memory, but we want to tie it to a reference, and we'll have a string here, and it's basically tagged. It's like, hey, I'm hooked onto this guy, and I'm good, and I'm going to remember this. And then we had another one that was it 8?
Mm-hmm.
And then that one came over here, and now we have that one saved as C.
So now when I type C, JavaScript knows that I'm talking about that 8.
Yeah, because now we know, hey, we've got these 2 tags that you've declared, that you've made, right? You've made these tags, and you've assigned it to a value. And now we can actually take those 2 things, and we can operate on them, right? So then we can put a big operator here, and now we have an expression. So that's all fine and dandy, but what gets really neat about this is, let's say we wanted 6 to, or let's say we had something else that, this is a good example, actually. I used to think that if you'd say, I want to equal this value, remember this is as low as we go, right? So I want to say, let's just say E is equal to D.
Mm-hmm.
What that really does, because this is a value, it goes, remember we can't get any lower than that. It goes to that value and ties directly to that. So now if I change E to something else, let's say I decide, I want to actually equal it to C. It doesn't change this relationship with D and the 6.
Mm-hmm.
It just takes this string and assigns it to over there. This is really key to understand because this only happens on the value layer. So we're as low as we can go with the values.
Mm-hmm.
Now, what if we want to have a collection of values? I think that's what runs us into our objects, right? Is there anything else that you wanted to say on this?
Let's try this in code.
Okay. So
yeah, do the tags in.
So if we were to write this, should I erase it now? It's kind of big. Let's go over here. We'll just write under here. So we first said D is equal to 6. Then the second thing that we did is we said we wanted E to equal D, right?
Mm-hmm.
Then we said...
So at this point, when we got to E equals D, then the string's going over there now.
The string's over there at first, right?
Okay, so as we said D, and E, it doesn't tie to D because D's already a tag.
Correct.
So it ties to whatever D is tied to.
So what I'm trying to say is that these tags can't tag each other. So you can't have E go and tag to D. And I'll get to that. You can do that with, we'll get complicated in a minute. But just remember that when it's down to its base value, to this lowest value, like a bool or a number or a string, it goes directly to that value. You can't go from tag to tag. Even though we reference what it's saying is, we'll just take my value and it sticks it there, right?
Mm-hmm.
So now we come down, we assign C to 8, and now we're like, oh, never mind, we want E to equal C.
So now we've erased this string.
And now it's coming back up to there. So now, as long as we understand how that works, I used to think that now D was equal to 8, but it's not. D is still tied to 6, and now E is tied to 8, and C is tied to 8. It's a wonderful, wonderful thought process there.
Okay, yeah, that's great.
So now, the reason why it actually doesn't really interfere is because it takes the values and copies them. But this is a good analogy because in reality, what would happen is you're like E equals D. It goes, oh, it's a 6 value, so this guy is alone with a 6. Does that make sense?
Yeah.
But we won't get into that.
Because that happens with primitive things.
Yeah, so primitive things, you don't really mess with those values. So now let's talk about something a little more complex, and it's called an object.
I should say that primitive things are values that we
Yes.
talked about. They don't get down any further than the number or the string.
So primitives, I don't even know if you can see that. Am I way too high? It might be.
No, that's good.
Okay, so primitives are what you called values, right? The very
Uh-huh.
base values. And those very base values are number, strings, and Boolean. So Boolean is just simply true or false.
So where a number can be pretty much any number that you can imagine between -4 trillion something.
Isn't that what they do for infinity? Well, I mean, you can't really go that high, but
You can
essentially.
imagine even a number in JavaScript is between negative and positive for all
Right.
intents and purposes infinity.
Correct.
So it can be any of those values. A string can be anything you can stick between two quotes.
So it's basically any kind of words that you want to put.
Uh-huh.
That's the way I describe it. It's just like words in a book. And this is actually either false or true.
There's
Right.
only two possible Boolean values.
So you really have an infinite amount of possibilities here in the strings as well, because you can put any combination you want. But those are what we talk about as our primitives. That you don't go you can't get any further down in JavaScript.
Yep.
So with that being said, this world isn't that simple, is it?
No, like I have more than just a name.
So let's actually do a collection. So what happens is you find a need to create kind of a structure to hold data. Let's say I wanted to represent Ben. So what in real life, if I wanted to keep something together about something, I'd probably stick it in a bag, like a grocery bag. Like, yeah, I want to remember these things, so I'm going to stick them in a grocery bag. So what happens is, if you can think about this, we'll just do a real simple one, but we'll have a tag called name, right?
Okay.
And then another tag called age. So now we're really simple, but I want to keep these together. They're important to me that they stay together, because I don't want to confuse them with anything else.
Because they're both talking about the same person, really.
Exactly, so it's talking about Ben. So I want to put this in kind of a bag here. So we can have a bag that just stores all that data.
Okay.
Okay? And we'll call that bag bin. Or should we let's call it bin for now. So what this means is we've now have a bag that is describing bin. Right? So if you wanted to write this out, we'll go into JavaScript in just a little bit, but I want to assign bin's name. Right? So what you do is we do this thing again. Right? We do this thing again. I don't know how old you are, but we'll just say you're 30.
You're very good.
So now we have these tags, and they're going to these values. You'll notice that. What if I want to? So right now in code, if I wrote this out, I would say bin is equal to. Let's create the bag. Look at this. It even has a bag type looking thing, right?
You're right.
I created a bag, and this is called an object literal in JavaScript. And I created the name. So I would suggest to write capitals like that, but doesn't matter. And this is how you do the colons, and then you assign it to bin. And then the next thing is I want age. And that's going to be assigned to 30. So this doesn't look too foreign. And now we closed our bag. This is how you write that in JavaScript. So now I have something that represents you.
Okay, one thing real quick. You gave the bag a name.
I did.
So shouldn't that be a tag like the other things?
It's somewhat like a tag, but what it really is you're right. So what this really is just...
So it's possible to have that bag, an unnamed bag, right?
Correct. Matter of fact, it is more or less an unnamed bag. Because what's really happening here is it should be, here's a tag, thanks for saying this, is really bin is tied to, it's actually tied to this here, this bag.
Okay.
So now...
So just like when we were doing the more primitive things, the equal sign made a tag, and strung it to a value of some sort.
Yeah, that's exactly right. So the equal operator is what ties those two things together. So you could actually come in here later and take this tag and assign it to another. Let's say there's another bag over here, right? Has a box of candy, and then say, never mind, I don't want it to go over here. I want you to be over here with other values, right? That have a name and an age tag. Does that make sense?
Yeah.
Because I'm not sure if you can see that even on that video.
Yeah, we're good.
So in all reality, this is just a bag. Maybe we should call this bag. It's just a description of things, right? It's just like a person.
It's a collection of attributes.
That's a good way of explaining it. Collection of attributes. So at this point, what I wanted to show you is that when you write, so you saw the JavaScript and you saw how the tags worked. So let's say we wanted to create a tag that referenced, let's do this. This is what was hard for me to understand. Is I can actually say this is equal to bin. So the bag's equal to bin, right? And I can come over here and create another tag and assign it to that bag as well, and we'll call this Benjamin. Benjamin. So now we have two variables that point to the same object.
Interesting.
So if I can assign Benjamin to something else or Ben to something else, but you can also go further because now I got reference to the bag, right?
Mm-hmm.
And I can go from the bag to its tag, the contents inside of it.
Mm-hmm.
And how you do that, let's do with Ben because it's shorter. How you do that is with this string, with the movement to that string means is kind of like the period. So it's the property accessor is what they call it. So you're saying, hey Ben, so this is like your dot. So this string is your dot. I'm going to go on this string, and I'm going to go to Ben, and then I'm going to access something inside of that bag.
So now that you've hit the dot, you can now get at everything on that next level.
Get everything inside the bag. So now your realm is now just in here.
Okay.
Before it was a bigger bag. You're in a bigger bag, now you're going to a smaller bag.
So we're getting more specific.
Getting more specific. So now we have Ben, and when we say dot, it jumps to the bag, and I say, I want to get your name. And it actually will return, so the next thing will be Ben at that point, right? And return Ben. So this right here, I'm now able to access, because what I did is I said dot name, it went here, and then went to go get the value. This says, hey, go get the value. It goes and gets the value.
So that would qualify as an expression, because it evaluated to a value.
Precisely. Exactly. So you can say this here is an expression of property access. I want to get the attributes or properties or the contents of this bag.
Mm-hmm.
I want the values out. Now, what happens though, this is where it gets really interesting, is if I say ben.name equals Jared, let's think about what's going to happen here. Remember, we have two tags tied to this bag,
Mm-hmm.
and now I've just assigned to name another value. So let's write Jared over here. What have I done with this string? The tag's still there, right? It's inside that bag. So I just got rid of the string pointing to Ben, and now it pointed over to Jared. What is Benjamin? So now if we executed this, remember how this is a property accessor. What is this going to say? Remember, we just said it. So this is actually going to return Jared. Because what we did is we changed this tag's reference to where it was supposed to be. That confused me because remember when I told you earlier, when we had the C and the D and this example here, let's write it over here. You have the D and then you had the C and then you had the, let's just have a 6 and an 8, right? I told you that you don't really affect this tag.
Mm-hmm.
Well, you don't affect the immediate tag because remember now we're jumping from thing to thing. We're going into a bag and then going out to get to the reference. This right here confused me for a long time. But once you realize what these arrows are doing or these strings are doing, you realize how it's assigned and how it's saved, your mind starts to clear up. I hope you're translating for me, Ben, because you're a lot better at explaining this stuff. But let's go a little deeper. Let's say there was something in here, like let's say your spouse, for example.
Okay.
I want another bag of data.
Oh boy.
So here we're going to go real deep here. Now we have a bag inside of a bag. And this resembles, let's just say this here just has a name. But this bag here has to have a name on it, and we're going to call it spouse. Like that. Okay?
Okay, so this isn't a tag inside my bag.
No.
It's a bag inside my bag. It's a tag and a bag in the bag.
Exactly. So you think, well, why would I ever want to do that? Well, you might want to know, you might want to hold more complex stuff inside of an object. So an object inside of an object, that's what this represents. So now, how do I get to that? I want to find out what the spouse's name is. So I would say Ben. So let's jump from thing to thing. So we go Ben. Here's the first dot. Here's the first dot there. It goes to the bag. Then we say spouse goes to this. So that dot goes to this bag, right? So here's the second dot. Then we say, hey, what's the name on this thing? We go to the tag, and it returns us a value. Right now it's nothing. So let's assign it to something. So now,
what would happen if I tried to access a tag that didn't have a value?
by default, it's undefined.
So it would just say undefined.
Undefined. You haven't defined it.
So you might say that every tag has a value called undefined.
Correct. So let's say you just created a tag out here, just willy-nilly, and you're like, let's call it nothing. That tag is undefined.
Undefined. Doesn't have a value.
It doesn't have a string. There's no string to any value. So it's undefined. And some people they like to preset their values to null, but that's actually a value. Because null is up here, right? And we're just tying the string to it.
Yeah, no, there's null and undefined and a couple other special primitive values that we didn't talk about, but know that there is such thing as, there's the thing called null and a thing called undefined. And
Correct. But undefined represents a tag that doesn't have a string. It's law. It doesn't have an owner, I guess is what you could say.
A stringless tag.
It's a, yeah. So I hope I didn't confuse all of you. I'm going to turn the time back over to Ben to clarify half the things that I said. But this is, when I realized that this is how the whole system works inside of JavaScript, how when I want to create an object, it's actually a bag that's holding the contents, and I can actually put bags inside of bags, right? It's just kind of compartmentalizing data inside of there. And each one of those dots is the string that gets me from one to the other to the other. It really started making sense to me. It also made sense to me why Benjamin's object, so to speak, right, that he's tied to, was changing out from under him because it was data inside here that's collected and showing,
Right.
going to different places.
So I guess the thing to remember is the distinction is made on these primitive values. This is not a primitive value, it's a bag. This is a primitive value.
Yeah, you can't go any deeper.
Okay, and we should say that these bags in JavaScript have a name. And
Yes.
that name is
Dun, dun, dun.
object.
Amazing.
JavaScript is built on 2 or 3 pillars. Maybe I'll count them sometime. But object is one of the pillars on which the language stands. Just by understanding this that Jared drew, you are, 40%
I would
into
say.
becoming a JavaScript master, and you're still in 2nd grade. Okay, so that's cool. We are running out of time, but I want to drive it home with one more
Yeah.
little example.
Let me help you out there.
me.
I gotta make sure that I don't draw clear up here anymore.
I just need a stool or stilts.
There we go. We'll put a stool here next time for you.
Okay, I want to talk about the second pillar of JavaScript. Now remember when I was trying to train my son on how to be a programmer this morning, he's 6. The thing that he wanted to do was see if it could do a word problem. And I told him, I don't remember what I told him, but the answer is Yeah, sort of, but probably not the way he wanted to do. So we've talked about values and expressions and operators and all of this stuff. When you're writing a program, chances are you're writing it so that you can solve a problem that's pretty common, a problem that comes up.
It's recurring, so to speak.
Yeah. Okay, so we're going to go back to the word problem. We'll say...
What do they call them? What are they called?
Story problems.
Story problems.
Yeah.
Essentially, that's...
So say we have Jane. And Jane has 3 apples. And then there's Bob. Bob has 6 apples. How many apples do they have altogether? This is pretty trivial, I know. They've always got 9 apples, but just for the sake of it, let's make this into a program.
Right.
We'll say Jane's apples equals 3. Bob's apples equals 6. So then all we have to do is say Jane's apples plus Bob's apples. I wish I could write as quickly as I could talk.
I think it just takes... It's perfect. It's the right amount of time for me to compute what you're trying to do here.
Now I'm going to hit enter and get 9. This, folks, is a computer program.
Or in other words, it's really a story problem.
Yeah, it's essentially a story problem. It's figuring out how many apples Jane and Bob have together. Well, what if the next story problem down says, now Jane has 17 apples and Bob has 3 apples.
Oh, you mean I'm going to have to write that all over again?
So we're going to have to come out here and type out Jane's apples equals 17 and Bob's apples equals 3, and then we'll hit enter again and get 20. Programming was invented to do this sort of thing over and over again.
To save those things.
So I'm going to show you a magic trick.
They called those, in the first days, I think they called them subroutines.
Yes, they did. In like BASIC, you would have line numbers, and then you'd have this on line 20 and line 30, and then you'd say, go to 20, and it would jump up.
And so we digress.
We don't have to do that anymore. So I'm going to get rid of this assignment part there.
Well, that's nice.
Just leave this thing here and say function count apples. And I'll explain the notation here in a second. Jane's apples. Bob, not Dob. Bob's apples. I'm going to wrap it in these fancy curly brace things.
Very well done.
Put another one down here. Now there's one thing left to do. We have to say return.
So you actually, what you're saying is I'm going to put, they call that top thing, I think this is critical, this is something I didn't understand until I was a lot further, but they call this thing here a function signature.
Yes.
And that's really important to understand, because the function, right, if you reduce this to its bare necessities, is that it takes 2 parameters, we'll just say arg1, right? And
sometimes we call them sometimes parameters, sometimes we call them arguments.
I guess we should probably stick to one or the other.
You'll
but
hear
they're the
those
same. But they're synonymous, yeah. So if someone says argument or they say parameter, they're the same thing. But this here is a function signature. But there's one key thing. What does it return? See? Where he says we give it 2 things and it returns
one thing.
One thing. So it returns the return argument of some kind of number.
And in other languages care more about this than JavaScript does. One thing that's great about JavaScript is it doesn't care about much of anything.
Right, you just tell it what to do and it does.
So I just made a new function. I gave it a name, count apples, and if you want to know a secret, this function is actually a value like those others we were talking about.
Right.
But you don't have to worry about right now. So I just made a reusable piece of program. So this function is going to do what it's going to do and then return the value. When you do something like this, 2 plus 3, you can imagine that this expression returns a 5.
Correct.
Okay?
So you just made your own, if I understand correctly, you just made your own expression.
Yeah, I made a reusable expression. I made an expression stamp that you can just go.
So show us real quick, the
Okay.
code underneath.
So now I'm going to use my function. Count apples. Let's see, the first one, I don't remember. We'll do 17 and 3. So I say, hey, count apples function, I need you to do your work. And you need these numbers to do your work. So we do this and hit enter, and I'm going to get back 20. This 17 will go up here to Jane's apples. The 3 will go up here to Bob's apples. And we'll have 17 plus 3, that'll be 20, and it'll get returned. And this kicks the value out of the function and gives me the 20 back.
So what's important to note too, this is where I got confused, is when you make a function, you don't know what's going to be passed into here.
Right.
This is what this is for. You're saying, hey, stick this value right here, stick this value right here, and then go wherever those are, replace them.
So remember when up here we had Jane's apples equals 17 and Bob's apples equals 3.
Mm-hmm.
This is a shortcut for doing that.
Yes.
This says Jane's apples equals 17, Bob's apples equals bleh.
You're doing
3.
good.
And then it kicks it out. So this function you can think of as a black box. You will use hundreds and hundreds of functions that you don't even know how they work inside. And the beautiful thing about programming is you don't have to.
Right, you have to think about it once.
I need a function that adds things together. So we'll just find an add function and you solve every problem one time.
That's right.
And then reuse that solution over and over again.
So that's the whole purpose of programming, is to streamline or to automate our complicated problems from day to day.
Yes. 16 and 12. This is going to give me another answer that I'm too lazy to add.
28. No.
Yeah.
Yeah.
Yeah, 28. So, that, I don't know, you're like 50% into JavaScript now.
So at this point, it really becomes clear that, like, I liked how you explained when we first started that an expression 1 plus 1, this here, is an expression. What's interesting is what you created here is just an expression of adding.
Mm-hmm.
But a lot of times you would have probably made it more complicated by saying it's not just adding because it takes 2 of the operators, right? They wanted to get some kind of average.
Yeah. Oh, let's see.
So
we can make this
average
average apples and then wrap that, divide it by 2, and
precisely. So
ooh, this is good.
Okay.
So I'm going to make one more function. I'm going to leave this one as is. This is cool too. Remember, an expression is anything that can evaluate down to a value. So I'll make a new function. Call it average of 2.
there you go.
And then it'll take one value, we'll call it the sum. And then it returns
The
sum divided by 2. Now I can say,
you have another function.
oh wait, no, this isn't what I was going to do.
It's a good idea though.
Sorry. We'll just call it average. And it takes two things,
Yes.
A and B. So, and then we need our curly brace. And what this is going to do is return count apples A, B, divided by 2.
Wow, so you're telling me you just made something that not only...
I'm reusing reusability.
So let's write a
Okay, let's do over here.
right. To the average,
3
and
and 9. I may have to run this one through a computer. Okay, so let's step through this one step at a time. We have this average function. This is called invoking the function. We're going to take these two values, 3 and 9, and plug them into A and B.
So let's do that. So 3 and 9, right?
Okay. So now we want to count
So
apples.
3 to 9.
Now at this point we jump up here to count apples. We're going to put in our
3 and a
and
9.
9, and that is going to evaluate to
12
12. Now we're going to return the 12. This part then,
gets reduced.
you do this in blue.
Okay. Yeah, this gets reduced to 12.
Now we have a new expression, 12 divided by 2, which
Gets
in turn
reduced
gets
to
reduced to
6.
6. It's returned and out kicks the number
Perfect.
6.
That's as simple as it gets. So now
Beautiful.
that's the simplicity of a language, but you can imagine the complexities that you can take on with this because you piece it out little by little. Good programs don't do heavy lifting in functions. They do little snippets of a very focused and purposed
Right.
execution. So this right here is very specific and saying, hey, I only do averaging, and this says, hey, I add them together.
Mm-hmm.
So with those two together, it makes very simple code and easy to follow.
Your whole job as a programmer is to identify and break down problems into the smallest pieces possible. And then to solve those little problems one by one. Then combine those small problems into, or those small solutions into bigger solutions, and eventually to solve the whole big problem.
Massive
And
problems.
The tools we've given you today are really all you need to solve just about any problem that can be thrown at you.
That's right.
In further videos, we'll go into some detail about some really useful, convenient things that help your life out
Right.
a lot, and talk about scoping and things like that. But really, this is the basics. You can do JavaScript now.
So this was our presentation of JavaScript 0.5 since we already had 1.
Yeah,
Right.
1, 2, and 3.
And we realized we went too far.
Yeah, hopefully this is useful.
So what we'd like to do is we're going to start simple, but we're going to have videos that are going deep, videos that will explain what tools we use and why we use them and why they kind of came about.
Mm-hmm.
So, but these are our first learning tools.
This is like your hammers and your nails.
Exactly.
This is the really bare bones.
When I built my own house, and I realized that there's really only a few things that I needed to build a house. I needed a hammer, I needed a saw, I could have a hand saw, I could have a hammer, and I needed a string and a level. I could build a whole house with those things. And the reason why is because, you know, those are the foundations of making things straight, making things plumb and level,
Mm-hmm.
and that's what we explained today.
Yep. So, thanks for watching. Leave comments. We've had 55 views on all of our 3
Wahoo.
videos to date, but no comments. So leave some comments and let us know how we're doing.
Exactly, and if you want to have us explain something that's confusing you, by all means say something in the comments and we'll make a video that explains that, and we'll talk about that.
We're going to get comments that say, please explain everything that Jared just said.
Well, okay. Well, that's what you're here for.
Just
You didn't do your job then.
You did a great job. I didn't have to.
All right.
See you later.